Okay, hopefully one more quick one here. We're going to imagine a stopper is tied to a string and swung through a horizontal circle of radius 0.9 meters. So you took some object and you tied it to a string and then you started swinging around, but it says it's a horizontal circle, so it's kind of hard to imagine this, but this isn't going up and down, but it's going just around and around and around. We're being swung with a frequency of 0.6 hertz. The radius here was 0.9 meters. The frequency is 0.6 hertz. And the question is, what angle will this string make with the ground? See, the trick here is that we're forgetting that if this is in the air, we're assuming no normal force, then the mass that's swinging around in the circle still has a force of gravity. And so, while a lot of the force of tension provided by the string is going to be causing the circular motion, the FTX component, there has to be some vertical component of the string that's balancing the force of gravity. So let's work through this and figure out what the relative sizes of those components are, and then we can use that to determine the angle that this thing must be making with the ground. So the force of gravity is 9.8 m. So the vertical component to the tension force must also be 9.8 m if this is going to be a horizontal circle and this mass isn't going to raise or lower at any point. These two forces have to balance each other. The centripetal part of the force of tension, the part that's causing the circular motion, we can predict using our formula for circular motion and in terms of frequency as it's given in this problem. So 4 pi squared mr f squared. And here I'm going to leave m lying around at the end and just plug all the rest of those numbers in, because I have m here, and then I'll have both of these things in terms of m and it will cancel out. So the radius I have is 0.9 meters. And the frequency is 0.6 hertz, or 0.6 per second. And then I'm just squared, and then I'm just going to leave the mass hanging out at the end. So let's fire all these numbers in. 4 times 3.14 squared times 0.9 times 0.6 squared. And I have an acceleration of 12.8, or I have a force of 12.8 m. I'm just going to hit that again, make sure I didn't screw it up. Yep, good. Okay, so this guy has to be 12.8 m. Now, if I consider the diagram that shows the combination of those two forces coming together to form the overall force of tension, this is 9.8 m, this is 12.8 m, and if I want the angle the string makes with the horizontal, I'm looking for that angle right there. So I can use the ratio tan to predict the angle. And I can see that the string would hang with an angle of 37 degrees. So when we imagine this thing moving around in a horizontal circle, because we're just paying attention to its direction, we're going to ignore the fact that really this string wouldn't sit horizontally. It'd come down at an angle, because it not only has to cause the centripetal acceleration, but it also has a component that's balancing the force of gravity that must be acting on the stopper. That's going to cause it to hang down at a lower angle. The slower it goes, the bigger that angle will get. The faster it goes, the smaller that angle will get. And that angle is going to, that angle is going to throw off any sort of experiment or something like that you might have done with these kinds of things. Anyway, that's how you can predict the angle.